Although the name of the Aztecs is widely known, a recent archaeological discovery has revealed a vast underground city in Mexico that promises to expand our knowledge of the Maya and their enigmatic monuments. Among these mysteries are the iconic Olmec heads, basalt sculptures weighing up to 50 tons. The choice of this specific material and the method of creating these pieces remain a challenge for science. But before we begin, don't forget to like and subscribe to our channel. For over 2 millennia, these silent figures have guarded secrets about their origin, location, and true purpose. It is known, however, that their structures were developed over different periods, being built directly upon the natural rock. For the first time, the use of artificial intelligence has enabled the scanning of these sculptures with an unprecedented level of detail, revealing a mystery that intertwines with genetic enigmas and completely unforeseen discoveries. The data points to manufacturing patterns that don't match known tools from that era, as well as hidden internal structures and details that defy logic. Instead of solving the Olmec enigma, the new analyses suggest that the origins of these pieces contain elements that, technically, shouldn't exist. The Olmec civilization emerged in what is now southern Mexico more than 3,000 years ago. They occupied the Gulf Coast region, especially areas that are now part of the states of Veracruz and Tabasco. The earliest evidence of their complex society dates back to around 1500 BCE. This civilization built ceremonial centers, used symbols that may represent an early form of writing, and left behind monumental works. Among its most iconic remains are the colossal heads. These are stone sculptures carved from basalt, an extremely hard and heavy volcanic rock. Each colossal head was carved from a single block of balstone. So far, 17 have been found. Each one depicts the face of a man with distinct features. Their expressions are serene, their eyes narrow, and most appear to be wearing something resembling helmets. These heads are not small. The largest is over 3 meters tall. The heaviest one weighs over 50 tons. Each one was carved from a single block of basalt, extracted from a mountain range called Sierra de los Tuxtlas. This region is located more than 90 kilometers from the Olmec ceremonial centers. At that time, there were no pack animals in Mesoamerica. The Olmecs had no wheels, no carts, and no metal tools. Even so, they transported these stones, and then they carved them using only stone tools. Modern archaeology still cannot fully explain how this was possible. Several theories have been proposed. One suggests that the stones were transported by rafts along the rivers. Another proposes that hundreds of people dragged the blocks using ropes and logs. But there is no clear physical evidence of these methods. The sculpture itself is also a mystery. Basalt is one of the hardest natural materials. Carving this rock without metal would require thousands of hours of work. Even so, the heads are not rudimentary. The facial features are well defined. The symmetry in the eyes, ears, and mouths is consistent. The features suggest individual identities. Many researchers believe they represent rulers. Others think they may have served as guardians or religious icons. There is no definitive answer. And the heads are not the only large-scale works of the Olmecs. They also built enormous earthen platforms, thrones carved from stone, and altars decorated with mythological scenes. They possessed a system of symbols that may represent an early form of writing. They produced jade and ceramic figures of a high artistic quality. Still, despite all these achievements, no one knows exactly what happened to them. The civilization went into decline around 400 years before the Common Era. Later peoples, such as the Maya and the Aztecs, developed ideas that may have Olmec origins, but the people themselves disappeared. Much of what is known comes from what was left behind and what remains buried. These are vestiges of an entire civilization, a civilization that today occupies its place among the oldest ever discovered in the world. Heads remain the most famous and enigmatic evidence of their skill. The scale, the level of detail, and the effort required to produce them are inconsistent with what one would expect from a society without metal and without the wheel. Some of the heads show signs of reuse. Carving marks suggest that some may have originally been other structures, such as thrones or altars, before being transformed into heads. This points to an even earlier phase of monument construction that has not yet been identified. A head found in a place called La Cobata appears unfinished. Its face is rough, with the sculpture incomplete. What was discovered there was unlike anything that had ever been seen before. A single, colossal head, buried deep in the ground. This raised even more questions than answers. Why was the work interrupted? Until recently, archaeologists relied on surface studies, basic excavations, and visual inspections to analyze these heads. The physical limitations imposed by the size and weight of the sculptures were overcome when researchers adopted artificial intelligence tools to perform high-resolution scans. Using technologies such as structured light, laser mapping, and density modeling, the team was able to capture microscopic details and internal images that were invisible to traditional methods and the human eye. Although the initial results seemed routine, the software soon began to point out intriguing inconsistencies. Marks were detected in the inner layers of the stone that diverge from the expected wear on stone tools, as well as variations in density that do not follow the natural patterns of basalt. In one specific case, scans revealed hidden geometric structures beneath the surface, such as extremely precise lines around the lips that give the work extra depth. The symmetry and linearity of these details are so perfect that they defy current archaeological explanations, demonstrating that these heads are much more than simple monuments. Interestingly, the project wasn't born out of a search for anomalies, but rather for preservation. In the state of Veracruz, Olmec heritage faces constant threats such as erosion and vandalism, and old documentation techniques like plaster casts proved insufficient. Thus, the use of artificial intelligence was initially a conservation strategy to create the most faithful digital record possible of these works, ultimately opening the door to a new level of understanding of their technical complexity. This would allow for conservation planning, virtual restoration, and more in-depth studies of tool marks, wear, and structural changes over time. Nothing in the original plan involved searching for anomalies. Artificial intelligence was used to increase accuracy, not to rewrite history. The teams used handheld scanners capable of mapping the surface with a resolution of less than 1 millimeter. After the data was collected, everything was processed by artificial intelligence systems trained to differentiate between known sculptural marks, natural damage, erosion patterns, and environmental effects. The idea was to automatically identify any area that deviated from expectations. As the system deepened its analysis, it began generating alerts. One of the models identified a repetitive pattern of lines on the side of one of the heads. They were extremely fine parallel striations, visible only in the three-dimensional model. These marks ran along the side of the jaw, below a decorative element. They do not correspond to any known tool brand in Mesoamerica. They resemble abrasion patterns seen in modern machining processes, although this comparison is still uncertain. No Olmec tool known to archaeology would have been capable of producing such a fine level of control. The marks are too shallow, too consistent, and too protected from natural wear and tear to be accidental. Another scan revealed a shallow cavity near the base of one of the heads. It was circular and with extremely well-defined contours. This had never been documented before because it was located in the buried part of the sculpture. When the model reconstructed the complete object, the shape became clear. It resembled a recess-like depression, less than 5 centimeters deep. The reason for its existence is unknown. No similar feature has been reported in other Mesoamerican sculptures. In a third scan, the artificial intelligence system detected internal inconsistencies in the material's density. The head presented a small, yet distinct region within the crown, where the stone density was below normal basalt levels. The volume was irregular but closed. This could be a natural void. Basalt can contain bubbles or spaces formed during volcanic cooling, but the shape was more linear than spherical. It resembled a channel or shaft, although the scan wasn't powerful enough to penetrate completely. To check for possible errors, the team repeated the analysis using a different model and software. The same anomalies appeared. They were characteristics of the physical object, ignored for decades. As a control, the team scanned a head known to be unfinished, that of La Cobata. It displayed expected tool marks, jagged edges, and no anomalies. This confirmed that the artificial intelligence was neither exaggerating nor creating non-existent patterns. The system functioned as designed. The team also used photogrammetry to identify subtle reliefs on the surface. By comparing lighting angles and micro-shadows, they found what appeared to be very shallow carved lines behind the ears of one of the sculptures. These lines formed a grid-like pattern, virtually invisible to the naked eye. Artificial intelligence classified this pattern as statistically unlikely to be random. Another unexpected result came from the symmetry analysis. The system measured each half of a face to check for alignment. Most showed natural variations, but one of the heads displayed near-perfect bilateral symmetry in the mouth and eyes, more precise than expected for hand-carved sculpture. This does not prove the use of machines, but it suggests a level of planning or measurement that had not been previously documented in Olmec works. What makes this significant is not an isolated detail, it's the pattern. Multiple anomalies in different heads. This suggests that Olmec heads are more than just sculpted portraits. They may contain elements of architectural design, hidden structures, or repurposed stone. The scans also open up new possibilities about how the Olmecs worked. If some heads were modified over time, this means their history is layered. Some features may belong to different periods. This would change how they are dated and classified. The next phase will require deeper scans, chemical analyses, and comparative studies. Heads are not just artifacts, they are data structures. And only now are we learning how to interpret them. Impossible markings, hidden geometry. The more researchers scanned the Olmec heads, the less consistent the data became. San Lorenzo also had a huge artificial plateau. In this image, it's possible to see an extremely straight line. It was no longer just about external features. Something deeper was beginning to emerge. Elements that could not be explained by conventional sculpture, natural wear and tear, or known construction methods of the time. One of the clearest examples came from a head located at the San Lorenzo site. When the artificial intelligence system enhanced the internal image from the scan using fine-tuned light reflection algorithms, it detected a pattern that shouldn't exist. Along the inner curve of the neck, a series of symmetrical indentations extended vertically. Each one was evenly spaced. Each one had the same arched shape. The AI model was unable to associate this pattern with any natural fracture sequence or erosion process. The hypothesis raised was simple. The recesses could represent an internal reinforcement system or a pre-cut structure that guided the carving. But no known Mesoamerican technique corresponds to this type of internal modeling, especially basalt. This type of rock is not suitable for interior work. It's too hard. It cracks under pressure. Creating elements within the stone without compromising the outer surface would have required an understanding of stress distribution far beyond the tools known at that time. Another anomaly emerged in the material's composition. A separate scan using portable X-ray fluorescence revealed irregularities in the mineral content of the outer layer of one of the heads. The discovery of hematite and magnetite running across the forehead of one of the sculptures revealed that these substances, common in Mesoamerican pigments, were not merely applied superficially, but incorporated into the upper layer of the basalt during the sculpting process. This slightly raised mineral band had no apparent decorative function, as it ignored the visible adornments and crossed the lines of the piece. Artificial intelligence classified the area as anomalous by detecting significantly fewer microfractures in this section than in the rest of the rock, a characteristic unique to this unit and absent in control samples from the same quarry. Another surprising finding occurred when scanning the back of one of the heads, which identified a 5-turn spiral less than half a millimeter deep, extending for almost a meter. Although spirals symbolize elements such as water and time in other Mesoamerican art, their presence in a hidden area and in an Olmec sculpture is unprecedented. This evidence reinforces the theory that the pieces went through multiple stages of manufacture and were possibly reused from earlier monuments, such as thrones. However, this reuse hypothesis does not fully explain the existence of hidden internal markings or spirals. If they were remnants of older forms, such markings should be partially erased, but the data shows that they were preserved deliberately and intentionally. The basalt used in this sculpture also exhibited an unusual grain structure. When compared to control samples from the known extraction region, the match was not complete. Most of the basalt from the Olmec heads comes from the Tuxtlas region. This sample showed higher levels of feldspar and slightly different magnetic properties. This suggests that the origin may be another area of the same mountain range, not yet mapped, or even a more distant region. What connects all these anomalies is their invisibility to the naked eye. No archaeologist studying these heads solely visually could have identified these details. It was only when artificial intelligence-based scanning systems reconstructed its shape with less than a millimeter of accuracy that these characteristics came to light. The scans reveal a level of structure and complexity in the heads that had not been previously documented. The implication is that the Olmecs possessed more advanced techniques than previously believed, or that the heads have a much more complex history than previously thought. Scans suggest that Olmec heads may have been designed for functions that transcend mere public display, revealing hidden elements that reinforce their multifaceted nature. While the traditional view classifies them as representations of rulers or elites to symbolize power and territory, based on their unique features and adornments, data obtained through artificial intelligence points to a much more complex and enigmatic role. The discovery of 4 heads buried beneath a ceremonial platform in La Venta reinforces this theory, as such treatment indicates a process of intentional sealing or concealment of something sacred, rather than simple disposal. Similarly, the deliberate damage found on some pieces, such as flattened facial features, may not only be the result of political retaliation, but part of a ritualistic cycle of creation, display, and reuse across generations. Beyond the symbolism, the technical precision revealed by the technology is astonishing. The analysis identified patterns of mathematical symmetry with perfect alignments between eyes, nose, and mouth on millimeter scales. This level of accuracy is extremely uncommon in freehand sculptures, indicating that the Olmecs used highly sophisticated pre-marking systems, treating the monuments as ritual instruments planned with technical rigor. Some researchers believe this may point to modular sculpting methods or molds used to guide the artisans. This means that the heads were not just art. They were measured, calculated, and executed with the care of an architectural work. This pattern is also reflected in the orientation of the heads. At least 5 of them are facing cardinal directions: north, south, east, or west. This is common in Mesoamerican sacred planning. Temples, ball courts, and plazas were often aligned with solar or astronomical markers. If the heads were part of a larger spatial design, then they may have played a cosmological role, not only to show who ruled, but to connect the earthly order to the celestial order. One of the most unusual discoveries from the scans was the detection of recessed symbols on the back of a head in tress. Zapotes. The symbol was only a few centimeters wide, almost invisible even under grazing light. It looked like a cross inside a circle, something not found in other Olmec iconography. No one knows what it means. Some suggest it could be a directional marker. Others think it may have been part of a system used to align the head with other objects in space. In any case, it doesn't appear decorative. It was placed in a hidden location, not intended to be seen casually. There is also growing interest in the idea that heads were part of a memory system. In some ancient societies, monuments were used to store information. Position, scale, shape, and order could carry coded meanings. If the heads were arranged throughout the ceremonial spaces according to a specific geometry, they could have functioned as a kind of spatial archive. This would make them part of a living system of knowledge, and not static memorials. The theory gains strength when the heads are compared with other Olmec structures. Several platforms and mounds in San Lorenzo and La Venta follow proportional patterns. Some are aligned with river courses. Others reflect solar angles at important times of the year. The heads fit into these alignments, even when buried. This suggests that the planning behind their position was not random. Another point that reinforces the idea of multiple functions is the evidence of reuse. At least 3 heads show signs of having been recarved from older monuments. Tool marks that intersect at unusual angles, surface polishing that overlaps previous edges, and unfinished facial contours point to reuse. One of the heads features what appears to be a throne seat carved into the back, now almost invisible due to surface erosion. This characteristic would not exist if the block had been molded only once. If the heads were reused, it means they were not permanently sacred. They could be transformed, reshaped, and given new meaning. This flexibility suggests that they fulfilled a role that changed over time, linked to social cycles, shifts in power, or ceremonial needs. This once again contradicts the idea that they were static monuments. They were active objects, possibly used across several generations. None of these interpretations can be confirmed with complete certainty. But the scans revealed features that the public, and even experts, had ignored for decades. If the Olmec heads were merely portraits, their construction, positioning, and reworking would not follow expected patterns. Its size, materials, and orientation are more akin to other sacred structures than to decorative art. Its surfaces contain details too fine for casual display. Its placement corresponds to a ritual geometry, not a random arrangement. Whether ceremonial, astronomical, mnemonic, or architectural, the heads are not isolated. They are connected to the Earth, to the stars, and to each other. Perhaps they were not built to be seen. Perhaps they were built to store information, and data can no longer be ignored. The purpose of technology is not just to observe, it's a revelation. In the case of the Olmec heads, artificial intelligence didn't find an answer. It found something else. She revealed a pattern of mismatched details, inconsistencies, and hidden structures that suggest a deeper truth. A truth that remained buried not only in the ground, but also in the assumptions that guided centuries of study. From the beginning, these sculptures defied expectations. Their weight, scale, and the skill employed in their creation placed them far beyond what most would imagine for a culture without metal tools, wheels, or written records. But archaeology accepted this mystery as a sign of creative ingenuity. The heads were seen as striking examples of ancient art. Powerful, yes, but simple in meaning. The new scans have changed that. What the data shows is not a single anomaly. It's a sequence of them. In almost all the scanned heads, some detail didn't match the expected profile. It could be a thin groove embedded in the stone. It could be a void within the structure. It could be a line of mineral concentration that shouldn't be there. Each anomaly, in isolation, is not enough to rewrite history. But together, they form a message. The central discovery is clear. The current historical model is insufficient. The most striking finding did not come from the surface of the sculptures, but from their interior, where laser-based density and geometry simulations revealed inexplicable inconsistencies in two specific heads. One of them presents a long, narrow, hollow segment, similar to an internal shaft, while the other exhibits layers of material that completely deviate from the basalt pattern. Although traditional theories suggest natural formations, such as bubbles or cooling cracks, the symmetry and isolation of these voids, including a perfectly flat internal surface aligned with the base, indicate controlled and measured work, incompatible with random geological processes. The publication of this data in academic journals generated a cautious reaction, as the researchers limited themselves to reporting the facts and the process without resorting to supernatural theories or lost technologies. However, the report triggered a wave of new research and funding that revealed even more anomalies, such as engraved lines and polished depressions under the chin and jaw of sculptures in San Lorenzo and La Venta, details impossible to detect with the naked eye. Furthermore, artificial intelligence identified patterns of wear from abrasion, instead of traditional chiseling on at least one of the pieces. Although the Olmecs used abrasives on small pieces of jade, applying this technique to massive blocks of basalt would require tools and pressure control that have not yet been found in archaeological records. In addition, the level of symmetry detected exceeds what would be expected from a purely hand-carved piece, suggesting a much more sophisticated technical planning than previously thought. The facial axis of one of the heads deviated by less than 2 millimeters across its entire width, from ear to ear. For comparison, this is closer to the tolerance of an architectural work than a typical sculpture. It is unlikely that the human eye alone could maintain this level of consistency. The spiral detected on the recessed back of one of the heads remains unexplained. Its curves followed a mathematical arc. It was neither random nor decorative. It was a deliberate pattern, hidden on a surface that didn't seem to have been made to be seen. Together, these details suggest that the heads were more than just visual. They may have encoded something, not writing in the modern sense, but data based on form. In the same way that lines and shapes carry meaning in architecture, in ritual arrangements, in spatial memory systems. In many ancient cultures, knowledge was not written down. The architecture, the arrangement of the stones, and the geometry contained within them suggest that the monumental heads were part of a larger system that we are only now beginning to understand. Their orientation and internal structure reveal layers of a design focused on functionality, whether ceremonial, symbolic, or practical, ruling out any possibility of random execution. The use of artificial intelligence does not render the past incomprehensible through human means, but it does compel the evolution of our assumptions. Through new technological lenses, these silent sculptures reveal that ancient craftsmanship had multiple purposes, both visible and invisible, preserving knowledge that survived the disappearance of the Olmec civilization 2 millennia ago. The heads, as the most imposing vestiges of this culture, now reveal a hidden complexity. Recent data confirms real anomalies, marks of precision, and a material planning that defy the chronology and known tools of the time. This does not point to the impossible, but proves that what we thought we understood is far more sophisticated. With the publication of these scans and the refinement of the models, the focus expands to the surrounding terrain, plazas and buried foundations. The heads were never just art or isolated monuments. They were components of a system that is beginning to reveal itself, and our ability to process this new knowledge will determine future discoveries.